Okey, cuba cakap lagi.
Hai.
Okey, kali ni dapat pula.
Hai.
Okay.
Okey, saya buat magic sekejap ya. Magic sekejap ya. Magic sekejap. Okey dah. Okey boleh start
Boleh, doktor.
Korang ada baca tak? Have you read the notes? The in vitro part?
Yes, doktor. I did. Dah baca.
Understand or don't understand? Huh? Okay, as we have discussed before, okay, they are concerned on the use of animals, the killing of animals, and so on. So, scientists have tried to develop a more innovative and non-animal based experiments. Okay, I've highlighted some approach yesterday. Ada 5 kan. There are 5 approaches. So the main approaches, non-animal approaches, the most widely used is in vitro, number 5. Yesterday I show you non-mammalian models and so on. Okay. In vitro cell cultures. The rest depend more, and also sometimes the other one is the omics. Okay. The omics approach, microarray approach. The other 2 depends on the availability of the computer or software. This is expensive things. The software, everything. So not every lab, or even in JSB, our department, we don't have anybody who have this computerized modeling, SAR, QSAR model to be used as an alternative to study toxicology. Okay? So in this slide, we are more focusing on the in vitro toxicology. We are not going to discuss on the QSAR and so on. That is actually under pharmaceutical chemistry, I think. Dr. Farah will talk about it because she's been doing that with Perdana University. Okay, I think you have experience of or being exposed to in vitro toxicology during your experimentation, during your practical class, right? Or a visit to lab. Okay, so some of the lab that use this in vitro toxicology study is, for example, Prof. Daud, okay, and to study anti-inflammatory. Yesterday I talked about this already, okay. And then Dr. Abdah, Dr. Sharifah on cancer. Dr. Nur Hafizah is doing on neurodegenerative.
Itu apa?
Weh, sembang weh. Kang panggil abang tu turun Listen, okay. Lagi siapa? Dr. Nur Hafizah doing on neurodegenerative study, Alzheimer, Parkinson. So if you're interested in cell culture on Alzheimer or whatever, you can go and see her. And Dr. Nia also cancer and antioxidant. Dr. Asia antioxidant. Okay. So this what is this? Huh?
Ya
What is
Allah.
this
96 well
things called?
played.
Okay, pandai. Siapa nama?
Asma.
Okay, Asma. Tambah satu markah nanti
Thank you,
Alright,
Dr.
this kau remindkan saya tambah satu markah. I add 1 mark for your assessment nanti. Okay, cytotoxicity in vitro toxicology is used to screen, okay, for cytotoxicity, meaning if a compound, whether a compound can cause toxic effect on the cell. Okay, let's say okay, I give you one example. For example, in anti-cancer study, okay, okay, battery low, tunggu sekejap. Okay, for example, anti-cancer study. So, what type of cancer are you trying to study? Okay, your supervisor will give you what type of cancer they want to study, what type of extract they are going, or compound substance they are trying to study. They want to prove the substance have anti-cancer activity on which type of cancer. So there are various type of cancer. For example, I show to you here. If you are talking about colon cancer, the colon cancer itself, there are so many type of colon cancer. HT29, HCT116, CACO2, liver cancer, so lung cancer, and then you also have various type of normal non-cancer cells. Okay, so when you do anti-cancer study, for example, you have to have that particular cancer cell, and you also have to have normal cell. Okay, why? Why? Because when you test a substance against cancer cell, if let's say that cancer cell if that substance kill the cancer cell, we have also need to know whether that substance also kill normal cell. Okay? So if it kills the normal cell, then what we can conclude, the substance that you tested is toxic. Even though it gives positive result that it can kill cancer cell, it also kill normal cell. You don't want that kind of substance to be administered into your body, right? Okay. So what I explained in the second and third point. If any compound can kill cancer cell but also kills normal cell, they are considered toxic. So you should terminate the experiment using that compound. Okay. And if a compound did not kill normal cell but it kills the cancer cell, then further pharmacological potential can be explored. Let's say you want to see the mechanism of anti-cancer involved, you can do that. So this different type of cancer cell is due to what? Due to the source. Okay, whether from animal or human. From human, it can be from an African born with certain type of cancer cell or certain type of disease. Okay, it can be from a Caucasian male or Caucasian female, African male, African female. Different depending on the disease, okay, or the animal itself, whether it have been induced or it have cancer or it have disease, what type of disease, okay. So and then the type of cell itself, whether epithelial or B lymphocyte and so on, that what make the variety of cells available for a particular cancer. Okay, and you can choose any of these cancer cell for your study. So we go back to the screening part. The Other than that, you also want to see protein binding. If you want to study protein binding, or you want to look at cytochrome P450 inhibition or induction, if you want to see membrane permeability being disturbed or not on a cell, if you give your extract, what happened to the membrane. Okay, you want to see metabolic stability, whether there is changes in metabolism, okay? And then interspecies for interspecies comparison, okay? Because you have different type of cell, so you can do that using in vitro toxicology. Okay. Okay, I told you just now, cytotoxicity is toxicity to the cell. So it can be used to assess viability, structural effects, and or function of the cell. Okay. For example, cell proliferation, whether there are decrease and increase in number of cells, whether if you give your substance, you give your plant extract, whether it can reduce or increase the number of cancer cell, for example, or it can reduce or increase the number of normal cell, for example. Okay, if it can increase the number of normal cell, it is good for your body. For pharmacologically, it's a good extract or substance. If it can increase the number of cancer cell, then it is not good to be consumed. Right. Okay, and then for you to study the structure of the cell, for example, membrane integrity, whether there will be loss of membrane integrity, meaning to say, for example, mitochondrial membrane inside the cell, okay? Because mitochondria is important for energy and energy production. And so if it can cause damage to the membrane integrity of the, if a substance can cause membrane damage, or it can disturb the membrane integrity, then it can damage it can disturb the function of, for example, mitochondria, okay, the organelle inside the cell. And then functional, you want to assess a function, okay, for example, similarly, you can also assess the mitochondrial function, okay. So this is what we mean by cytotoxicity. I explained this already. So this is an example, no? Is the normal life cell, if it is cancer cell or normal cell, then after you give your substance, you do the cell viability test using 96 plate, well plates, then after you take a picture, okay, you stain the cell with certain staining agent, then you can see there is damage or changes to the structure of the cell. This is an example of that cell. Okay. And then another picture to show you changes that occur. You can look at under light microscope and under fluorescent microscope. Quite interesting study in vitro. So here you can see a control normal cell, then those cells that have been treated with COD or COM, you can see the morphology have changed. Okay. So this is cytotoxicity effect. Okay, the cell have been damaged, the number of cell is reduced, structure have been changed. Another different staining to see the mitochondrial function. Okay. We go to. Okay tak? Any understand? Any question?
Understand.
Clear,
Boleh kan?
doctor.
Understand, doctor.
Understand, doctor.
Okay. Okay, advantages. We go to advantage.
Ya, doktor. Boleh faham,
Advantages.
doktor.
Alright. Advantages of in vitro assay. First, it reduces animal use. Right, obviously. Then the test is cheap and fast. Cheap and fast. Uh, cheap and fast. Cheap means there are certain kits, kits the solution or certain chemicals that you need to buy. Some in if you buy in bulk, it is cheap lah. If you buy, your purchase is one kit, one set, one box, for example, then it will be a bit expensive. Okay, if you buy in bulk, then it will be cheap. And fast depends on the facility of available in the lab. Okay, sometime for example, the flow cytometer, a machine for measuring the anti-cancer activity, whether the cell is killed at which cell cycle stage. Okay, there are four cell cycle stage kan, GO, G1, apa tu? Okay, if you that flow cytometer, like in our faculty, it is in the lab of Associate Professor Dr. Maha, which is in the faculty, in Department of Pathology, if I'm not mistaken, pathology. So if you need to use this kind of machine, you need to book with Dr. Maha, and then you have to go bring your sample, from JSB to pathology, medical pathology department. It will take some time. Your sample can be exposed to contamination and so on. So you have to be careful. So fast or not depend on the facility. Okay. Test compound needed in trace amount. So you don't need in milligram of sample. You need only microgram. Okay. So in for anti-cancer, and I think for most of the in vitro study, meaning using cell or using low phylogenetic animals, the amount, the concentration or dose, in vitro concentration lah, the concentration that is required according to USFDA for a substance, a compound, an extract, a pure compound to be considered as having an activity, for example, anti-cancer activity or anti-inflammatory activity, when you tested using in vitro assay, is 30 microgram per mil. The maximum, okay, 30 microgram per mil. Meaning to say, if your compound is 40 microgram per mil, still acceptable for you to proceed for your study lah. For example, if you do your master or PhD, you find out your plant extract or your compound have anti-cancer activity, anti-colon cancer activity at 40 microgram per mil, then you can still proceed to study all the mechanism and so on. Okay, but if you see this activity, the maximum anti-cancer activity at, let's say, 200 microgram per mil, then it is not worth it for you to proceed more. Understand? Because 200, the US FDA requirement for a compound to be considered as having activity is 30. The maximum is 30. If lower than that, that means your compound is very effective. Okay, if it is 15 microgram per mil or 5 microgram per mil, then it is very effective. But if it is 200 or more than that, then no point of you further testing it using whether in vitro or animal models. Okay, so this is the advantage of using in vitro first, then only go for animal study. Okay, you can decide whether your compound is active or not. Okay, based on the US FDA regulation. Okay, so you can use human tissues and cells. Okay, the testing sample is the human tissues and cells, and also animals. Okay, and as we mentioned earlier, it is suitable for screening. So you can screen because you have 96 plate. Okay, well, 96 well plate. You can put up to 10. Okay, maybe 10. You can put so many. Depending, 96 is 12 time 8, right? So maybe you can put 8 sample in your plate and run the experiment. So from there you can screen which compound out of 8 is the most effective one. Instead of testing one by one on the animal. So the most effective one you choose and proceed with further in vitro and in vivo study. Okay. Okay, possibility to use the same doses in other tests. So let's say you found out that your compound uh, can kill cancer cell, colon cancer cell at 20 microgram per mil. You can use that 20 microgram per mil or the range that you use for the colon cancer test, you can use it for other cancer cell, lung cancer cell, and so on. So, when you use the pipette, you don't have to change it. You can directly use it to take your sample and put in another plate containing other cancer cells. Okay, and then time response can be tested. Okay, for cancer, for example, you can screen the effect of certain extract or drugs on the cancer cell at 24 hours, 48 hours, and 72 hours. Then you can know at which time did your compound produce the anti-cancer effect, whether after 24 hours of putting the extract in the 96 well plate, or after 48 hours or 72 hours. Okay. You can see the number of cells decreasing as the time increase. Okay. That is the time response, what we mean by time response. And then you can study the toxicity, what type of pathway in the cancer cell that are being triggered, okay, such as caspase 3, caspase 9, caspase 7, NF kappa B, okay, TNF alpha. All this mechanism you can study using your cell. Once you tested it, you can take the because the cell is dying, it will release all the content, kan? So you can take the content and measure all these metabolites or enzyme expression inside the cell, whether the expression is reduced or increased. Okay? So from there you can determine the mechanism, hypothesize, can prove the mechanism. And then the advantage also is to decrease biological variability. Okay. So using in vitro assay, you can decrease biological variability. Okay, because if you use animal, there are certain variability, okay, which affect the result. Okay, Some species might not respond well to a compound compared to another species. And then lastly, human genes can be moved to cells. Okay? So this is the advantage of using in vitro assay. Depending on the type of cell, if you study on gene, you can transfer gene to cells. Okay? For example, if you study anti-cancer, then nothing involving gene lah. So this is just to tell you overall in vitro assay also the advantage is genes can be transferred to cells. Okay. Any question?
Yes, doktor.
Clear?
Doktor nak tanya.
Yes.
Kan tadi kan doktor ada cerita pasal FDA kan. Dekat Malaysia, kita ada standard requirement minimum untuk dos kan. Kita nak follow mana kat Malaysia?
Normally in Malaysia pun we still follow US FDA because it is used worldwide kan. In the end you akan if you let's say your product, your compound, your extract is effective, kan? So you want to come out with product, you will not only produce your product to be used in Malaysia, you want to market it all over the world. So normally we follow US FDA as our guideline lah.
Okay.
If you did not follow US FDA, let's say Malaysia come out with their own value, let's say they say 50 is considered effective, then you cannot sell your product definitely in US cannot, and maybe in Europe also you cannot. Okay, so it's better to because everything pun if you know everything that we do, any law pun normally we look at the Western lah. They set up the requirement lah, kan? So normally macam tu lah USFD, because in paper pun if you look at paper discussion when even paper from Africa ke from India ke from Asia ke Japan whatever, when they discuss their finding, they will mention USFDA requirement is 30 microgram. So our compound or our extract therefore can be considered as effective. So dia orang pun refer to this requirement juga.
Okay.
Right?
Okay, thank you.
Okay. Okay, disadvantage of using in vitro assay. Okay, some cell culture have low proliferation capacity and high phenotypically changing capability. Okay, it is not possible that in vitro test may represent in vivo condition under such circumstances. Okay, certain cell they have low proliferation capacity, meaning if you take a certain amount of cell you put in the media to make it you put all the media, all the nutrients to make it proliferate into certain amount of cell. And some cell is difficult to proliferate. So that's why when you choose a cell, you need to refer to previous literature, that's why you need to do literature review and so on, which type of cell is better. Okay, you for example, I show you just now in the earlier slide, for colon cancer, you have HT29, HCT116, CACO2. Which one is the best? Okay, depending some of the cell might have low proliferation capacity, so difficult for it to proliferate. Okay, so if it is difficult to proliferate, let's say you put 10 cell in a media, you give nutrient and so on to make it proliferate after 1 week to get around 6 to the power of 10, 10 4 times 10 to the power of 6. Okay, normally for in vitro, if I'm not mistaken, 4 to 5 times 10 to the power of 6 number of cell. You need that amount. So if you put certain amount of cell, you want to make it proliferate. Certain cell have this issue. They have low proliferation capacity. So it is not suitable. Some cells are not suitable to be used for in vitro study. Okay, and certain cells, they have phenotypically changing capability. They can change their phenotype inside, and the genetic part they can change because of we left them to interact with each other. They might develop certain type of immunity, for example, okay, compared to the parent cell. Then the first cell, which maybe if exposed to your substance can be killed easier, but after you let them for several days to proliferate, because they change their phenotype capability, they have this changing capability, so the cell is not functioning as what it's supposed to function. Okay, so this is what that's why some in vitro tests may not represent in vivo condition. Okay, you cannot get direct, similar condition when using in vitro. You cannot assume that the condition that you use for in vitro is similar to in vivo condition. Like I told you yesterday, because in vivo, you have liver to do metabolism on the substance, okay, and you have learned pharmacology. If you know, certain drug, after they being metabolized in the liver, they are more effective than their parent compound. Let's say paracetamol. Paracetamol is toxic, but after it go to the liver process it to produce its metabolite, NAPQ1, NAPQ1. This NAPQ1 is really highly toxic, and it start to causing damage. That's why if you consume paracetamol more overdose, you can get liver damage and you can die because of the excess production of the metabolite of paracetamol. Okay, so this kind of thing makes the in vitro impossible to represent in vivo condition. Okay, some cell cultures, especially primary cell cultures, cannot show clonal growth and show loss of viability in short periods of time. Okay, some cells they tend to die. Okay, to die, they have short period of time of to live lah. Okay? So you cannot be used for chronic toxicity studies. And then animal cell culture do not always represent similar result with human cell cultures because of the interspecies differences. So that's what I told you yesterday about curcumin, 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 which was found to be effective in cell culture, but not effective at all in the animal. We are talking about animal and human due to interspecies different. So animal, as you know, not always represent similar result to human. Definitely, for example, even in life in vivo life organism, human and animal, human and cat, for example. The cat cannot metabolize paracetamol. Another simple example: if you detect your cat have fever, you cannot give paracetamol. Okay, it will immediately kill your animals. Okay? Because the cat did not, the liver of the cat did not have the mechanism to metabolize the paracetamol, to excrete the paracetamol out of the body. So paracetamol will be in the body of the cat for the rest of its life, and it will die from liver damage. I have this experience. I've killed my wife cat. So we learn from mistake, and because I'm not a veterinarian, I don't know. I thought the cat got fever, so I give paracetamol. After one day, gone. Okay, it is difficult and costly to use human. Okay, another issue of animal and human cell culture is that the cost of using human cell culture is more expensive. This is some of the advantage, and then there are not definitive and precise test procedure for in vitro toxicity test given by regulatory authority. So you don't have a definite or precise test procedure. Okay, when you do your test, you have to sometimes modify according to your lab condition. Okay, according to your lab condition. If you read a paper on anti-cancer activity from UK, for example, okay, they are doing anti-cancer study on colon cancer, HT29, using HT29. So you want to use that HT29, you have to remind yourself that the condition in UK itself is not similar to us. We have a hot condition, and so whatever the condition they use in the lab, 42-degree temperature to maintain the cell, for example, you cannot use 42. Okay, it will affect your cell. So you have to adjust. That is why this kind of thing, normally the lecturer, after certain years, they have experience with the cell. Okay, they know, okay, maybe because of Malaysian condition, they try at 42, 43, 45 until 50, and 50 degrees Celsius was found to maintain the cell growth at maximum amount, for example. So that's what we mean by not definitive and precise test. That one depend on the lab condition. Right? Sometimes you have to modify the medium itself. But some people say 20%. Maybe you have to use 18%. Right? Because of what? Because of the product coming from different company might also have different activity, different effectiveness of the compound, even though the same, might be different between different company, right? Okay, so that is what we mean by not definitive and precise test procedure. You don't have a direct one procedure that you can follow and you get the result. No. Okay. Common harmful effects like weight loss cannot be measured. For example, so you cannot measure weight loss. Okay, if the compound have ability to reduce weight of the animal, you cannot see that in vitro study. Okay, certain, for example, salivation, diarrhea, you cannot see that using in vitro. Okay, and then systemic effect cannot be measured in vitro test. Okay? Systemic effect cannot be measured because you are using cell instead of using whole animal. Okay, specific organ effect also you cannot be studied because you are using cell instead of the organ. And how tissue and organ work together cannot be tested also. How the tissue and organ work together cannot be tested. So how the tissue work with the liver to heal certain disease. Okay, you cannot see that. Okay, you as I told you just now, liver especially, it can turn. For example, if you learn about Parkinson, L-dopa, the drug, L-dopamine, L-dopa, it can be turned into effective metabolite and produce a more good effect, good anti-Parkinson effect on the patient due to the action of the organs. Okay, so this is interaction between brain and organs for Parkinson. So you cannot see how they work, how the brain tell the liver to produce more metabolites that can help to reduce Parkinson effect. So there is disadvantage. Okay? So this is for your information. Okay, target organ cell. Okay, there are ocular and skin testing can be used. Okay, this is another table to show you the advantage or disadvantage. You can read it. Okay, this just the rest. I think this example of the type of in vitro models available. You can read through if you want, or you can go to search in the YouTube how these tests are being carried out. What is epiderm, how it is being carried out. Just for your information, we will not go detail on this. But please just at least remember the type of test: bovine corneal, isolated rabbit, chicken nucleated for ocular test, ocular toxicity. While for skin, maybe you have to know what type of test available. Okay, pig ear test, pre skin, and so on. But how the method is being carried out, that one you can Google if you are interested. But I think in our department alone itself, we don't have this type of study yet. Even ocular involving we have ocular for in vivo. We can do that in vivo, but in vitro no. So with that, I think that's all good. Habis kelas. The rest ni banyak-banyak ni is just for your information je. Ada soalan?
Tak ada doktor.
Faham
Faham.
Okey, esok kita test.
Doktor Syakira panggil.
Saya tak kelui. Apa dia? Loh, baru mas. Alamak. Saya tak admit dia lah. Sorry.
நம்பர் கொடுக்குறாங்க 1 மணிக்கு அடைக்கிறானா 50 பக்கம்.
Wei,
Hagilan, off your mic.
any question? Hello, any question?
Doktor, nanti nak tutorial.
Tutorial?
Mm-mm.
Boleh. InsyaAllah.
Oh.
Rasanya kena bagi I need to give you all assignment kot.
Boleh.
Bagi saya fikir dulu Okay, attendance as yesterday. Nanti baru ada. Belum ada lagi. Nanti you all kena log in and click attendance. So exam kita tak ada exam Syafira. Kita ada asynchronous and synchronous testing. Saya pun tak tahulah apa benda, tak baca lagi benda tu. But I think we will try to have an assignment lah, so that I can give you all tinggi-tinggi mark. Nak ke tak nak?
Nak.
Laju markah tinggi Meeting tadi cakap apa je, doktor? Update. Apa tu? Nak. Boleh. Marah lebih. Kat siapa? So, later I will tell apa nama your class rep, Sarah, right? I will tell Sarah how are we going to do the assessment. I need to ask Dr. Akira first. Okay. Okay, apa lagi? Any question? Satu markah untuk Asmah. Betul lah. Tak nak, bagi 2.
Oh.
Meeting tadi cakap apa? Ling Leong Fang. Meeting mana? Meeting dengan dekan. We are talking about publication of pensyarah. Our LPPT, our SKT. Sasaran kerja tahunan, our marks for 2020, how it will be assessed on the part of publication actually. Okay, they have changes the rules, increase our KPI. Because for example, like a professor, every year a professor have to publish 4 papers. Associate professor 3. No, doctor I think 2. Doctor 2. New lecturer baru balik, maybe 1. So this KPI we need to fulfill to get highest mark lah. And then the paper that we publish have to be within Q1 and Q2. There are 4 Qs. They rank it into Q1, Q2, Q3, Q4 like your MUET Tier 1 sampai Tier 6 kan. This one Q1. So we have to achieve the first and second Q1 or Q2. So that's tak ni lah. I mean among us je lah, bukan on the student part. Tak ada lah. Just because some of us tak puas hati kan. Kalau ada apa-apa nak tanya outside of this, you boleh tanya, tak ada masalah. Maybe for your
Doktor,
Is that?
nak tanya kalau
Azmin.
ada test, maksudnya final test Final exam tak ada ke apa?
Final tu kita akan ubah. Kita kena ubah, but we did not come to a conclusion yet. Nak assess macam mana, because this is the first time kan. So semua orang pun, even kelas ni pun semua orang pun pening. I hantam je ni. Nasib baik my wife tahu benda dia UiTM ni lecturer. UiTM memang advance lah, pakai-pakai online punya benda ni. So dia yang set up semua. Ni nak you all punya attendance pun kena tunggu dia yang set up benda ni. So I tak tahu lagi nak cakap ke you your final, yang I tahu final yang you have to sit, kena baca tu semua tu dah tak ada lah. Whatever yang sebelum ni dah tak ada lah. Maybe you are going to be given assignment ke macam tu ya. Or tutorial test kot. Ya.
Okay. Terima kasih doktor.
Alright. Oh, dah ada attendance eh?
Dah.
Okay, dah ada. Pergi sign.
Dah.
Alright. Ya, siapa? Syafira. Kelas
Okey,
lab
doktor.
instrument. Lab instrument bila? Bagi siap. Dia punya notes, I try to siap minggu ni. Notes dah ada. Nak touch up sikit. Lepas tu, I bagi notes kat you. Macam hari tu, semalam we discuss. You read the notes. And then we decide maybe next week, the second week of the online punya kelas lah. We are given 4 weeks, right? So on the second week, we will decide when we will have a class for you to ask question lah kot. Boleh
Boleh.
Because in the end, you assignment juga tu, nanti assignment je. Alright? Bagi masa sikit. So, anything else? Okay, kalau tak ada
Tak ada.
okay, if tak ada, kita boleh bersurai lah. Dia buat apa ayah oi? Nanti bawa balik sini bagi lecturer.
Thank you, doktor.
Yang mana mentor-menti dengan saya tu. Bawa main 3-4 balang. Mengadap. Okay.
Dia pun dekat kolej. Tak ada doktor. Saja je.
Oh ya. Yeah.
Tak ada. Okay. Terima kasih doktor.
Okay.
Terima kasih, doktor.
Oh, ada orang kat kolej. Okay, bye. Sama.
Bye-bye.
Okay, nak stop recording.
Yelah, doktor punya ni.